Hello, how are you doing today? It's me. I'm back. Okay, so what I want to do in this video, I want to look at the WebGL and its operations from different angles of view. Oh, what do I mean by it? First of all, our object in a canvas can be static, like it's right now, or it can move. I mean, that is light source. First of all, light source can be static, or light source can be moving. The object by itself can be moving, or be static. So we can move it, set it on certain position, or it can move to this position, and consequently, it's not static. We can move. Let me see it. We can move object with this. Oh, no. We can move object with this matrix. We can move perspective, not object, but the world by itself with this matrix. So that's what I want to explore in this video. I'm I'm exploring this kind of on my own too. So I can make mistakes here, can don't make mistakes here. I might be right. I might be uh, not quite right, but then I'll try to fix if I'm not right. Or you can fix me if I'm wrong. So let's start. Let's start. First of all, let's where's my paint? I need the paint. I need the paint. That's the paint. Let's talk about what? Let's talk about this. Let's talk about, let me write down a new one. Let's forget about this stuff. It's already we passed in the previous videos. Yeah, my WebGL videos, they are taking the space up right now. I can see it, but it's kind of interesting, at least for me. So I'm trying to explore it. And that's what this video is about. We're exploring it. And if you don't want to explore WebGL with me, then you can skip it and we can proceed after these videos to the next what I'm going to do. You can see already the given result, but I want we build finish result together of this thing. But for this we need to explore it. Okay, so let's talk about, let's say we will say model, it proposed to me 0, but we will not do it 0 right now. We will say 12, and we will say math, and let's do this. Okay, let's leave it. So it's already saying that it will be by x. We have sine, and that's what I want to talk for 5 minutes about. We can do this, or we can do that. So the question is now arising, what the difference will be between, I'll tell you right away, it's motions. Here will be the motions. That's the time. By the way, where is that? Where is this variable? Yeah, it's here. So that will be in kind of seconds. That's the speed of this motion. We can multiply by some number, and that becomes like seconds. So that's the time. And that is the distance. Distance here, as I understand, in absolute, how it goes, in absolute units. So we can't say it's meters or centimeters. It's absolute units. As I understand, maybe I'm wrong, but I think I'm right about it. Okay, so but what's the difference between this and that? So I don't know, like if we're setting up here, I don't know, I don't remember exactly. Oi, what I'm doing. I'm sorry. It's not right. I see I completely wrong right now. That's a Y. And then the X. It's so difficult to write down. So I might be wrong. I completely forgot my calculus right now. Like that. But I might be wrong right now completely. I'm sorry, but this will be a sine, and that's cosine. Cosine. Oh, sine and cosine. Oh, they might be vice versa. That's what I might be wrong right now. So they have different amplitude, aptitude, whatever you call it. So, but what we're looking at, and for some cases it might be important when your objects start moving. But for right now, it doesn't matter for us. So this is and this one are the same. There's no difference. They just started moving at different point. So we can use sine or we can use cosine. It's a different amplitude, whatever you call it. So that's the first one I want to call about. Okay. And I might sometimes will do a pause to think about what I'm going to talk next about. Okay, do I have recording going? Yep, it's recording. Okay, because I was making a pause, thinking about what I'm going to do next, what I'm going to talk about next. So let's say, so I hide my motions. Let's say I want static. We won't just statically move this object into the different position on X. For right now on X. I was talking about it, but I'll remind you about one thing. Where's my here? How can I can I make it? Okay, let's do new one. New one. Wait a second. Let me set it here. Now I'm going to save it. I'm sorry, I'm off screen, but it's better to do this way right now. I'm going to go to this disk. Where's my project? Okay, I'm going to save it as sine cosine. Just reminder for myself to sine cosine. I'm going to save it. I'm going to make new page. Okay. As you remember, hopefully, we have this is canvas. Yes, it has its z direction, how deep it goes into the area. But for right now, we like thinking about for right now. We'll be also thinking about z directions too. For right now, we're thinking about x and y directions for the simplicity. So that is y, that is x. And so that's maximum can be 1, that's maximum can be 1, maximum can be -1, and maximum can be -1. And on the z direction, well, it should be here, right? Like that. I believe that's 1. And I believe that's -1, but we need to check it later on because I'm not sure right now. It's a little bit tricky. It's yeah, I think I'm right. I think I'm right now. So in the plane we can move up to absolute unit of 1 objects. So if I say model 12 equals 0.9, guess where it will go? It will go on X. My Visual Studio tells you which it goes by. It goes by X to the right by 0.9 units. So let's see if it moves this way. Yeah, absolutely, it moved this way. If we say, for instance, why you don't want to, if we say 90, guess what? We're going to lose it. It's going to be, it's not going to be anymore in our canvas gun. It went right far away, I don't know, somewhere like 90 canvases off my screen. If we say -0.9, right? It's going to be moving to the left this way. And again, if we say -90 to prove the point, it's going to be gone 90 canvases from my canvas. It's like in our sun, our sun can hold how many Earths? So that's the same thing. So it's moving too fast. So each time we're moving beyond 1.0, we're moving off canvas. Okay, but let's make it 0, 0 right now. It will be right in the center. It will be right in the center by x. But you see, we can don't say it. It will move it. It will keep it in the center if we don't say nothing. Okay. Now let's talk about this matrix. Matrices are the usual deal for GPU. It always operates with matrices. But what's interesting, this matrix means lots of things. This simple matrix. Some people call it matrices. Matrix, all of good of these names. So let's talk about what this matrix mean. So we're going to have it here. I'm going to move it. I'm going to yeah. Let me take a pause so you don't struggle with me. So, oh, by the way, I'm on a different setup today. So it can be now 3440 pixels on your screen. If you want to, it can be less, but I think it will be much clean setup. Okay, so let's talk about matrix. Let's talk about matrix. It's not usual matrix per se. This matrix goes like this. We count in cells like this. It's 4 by 4 matrix. I'll count. Yeah, we count this way: 0, 1, 2, 3, 4, 5, 6, 7, 8. My 8 didn't happen. Just a second. It's not pretty 8 at all. I know it. You know, it's very difficult to write with the mouse. Try it yourself. So 7, 8, a little bit better, right? 9, 10, 11, 12, 13, 14, 15. Okay, sometimes when we're talking about WebGL, we're talking about these numbers. That will be M, 0, 0, M, 1, 1, 0. Wait a second, I'm wrong. Wait a second, that was completely off. 0, 1, and this one becomes 2 and 3, and here M, 1, 0, and that M becomes 2 and 3, and so on. So that will be 1, 1 here, and so on. So it's kind of normal matrix, how normal matrix works. But we are here not in a normal matrix, we are in weird WebGL matrix here. Like, come on, I want you to get off so you don't stay on our way. Here, get Okay, yes. Okay, good. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We call it mode 15 system. Mode 15 system. So what's the system about? We know already mode 12 is moving our object. Let me see. I forgot. Did I forget or not? I'm talking right now. Yes, I didn't forget. Okay. I'm talking about this matrix right now. Okay, so that moves this where is that? Mode 12. Either it's static, where is that? Either it's static or doesn't it absent completely, or either it's dynamic with the time and amplitude. It's always moving by x direction. So that's x. Mode 12, that's x. So we know that one, we know already. Guess what 13 will be? Let's well, I will not hide it from you. It will be y. So that's x. Oh my goodness, I can't try it with the mouse. That will be x. That will be y. So let's explore it. We will say model. Yes, model. Yes. Model. Evgeny, come on. Wake up. It's already evening time. Okay, so model 13. And it's already proposed to us not to get married, but to some code line. And proposed to us not again to be married. It's proposed some code for the line, and we'll save it. And actually, let's explore first static. We explore. We will say 0.5 up. So it's positive number, 0.5 up. Reload. Guess what? It moved 0.5 up. Minus will be 0.5 down. So guess what? It moved down. Now let's do dynamic. We'll say sine. The time will be, let's do 7 seconds maybe. Oh. Is it 7 seconds? And amplitude, so small. Why it's so small? Is it small? Yes, I think it is very small. Let's see. 7 seconds too long? It's not 7 seconds. It's let's say that will be the second, so it will be 0.07 seconds. It's too slow for the 0.07. Okay. So, but generally the idea is that greater the number here, faster it will move. So if we'll make, for instance, 11, please don't swear at me. You see, it's moving faster right now. So that's general idea. Okay, find how many seconds by yourself. Okay. For me, it's already good. Oh, by the way, what if we do this? What if I completely screw it up and I'll do this? Minus 11 seconds. What will happen? It will be cosine. Yeah. It will be the same. Yeah, it is the same, so it's cosine generally. going, oh, maybe it's a sine, but it's starting from the opposite direction, from x or y side, from down from here. Where's my, oh, so if we say minus 11 minus somewhere here, so it starts from somewhere here and loop and goes up somehow like this. Well, something like that. Okay. So let's that disgrace move it out. Oh my gosh, I need to make it bigger. It's too difficult. It's too difficult to wipe it out. It is very. Where's that? Oh. How can I make it bigger? Okay, let's. This disgrace will be staying with us. So that's dynamic. So what if we set here cosine, nothing will change. Just change the timing when it comes. It was bouncing from down, up, and down. Now it's bouncing from up, down, and up, but it's generally the same thing. So what if we do that? That's amplitude. Nothing will changes, of course. Yeah, nothing changes. Okay. Now let's do just positioning, static positioning minus 0.5. That will go down and just stay there. It just stays there. And it just stays up there. That's it. Nothing much. Let's remove it and come back to the middle. Now, where's our matrix? What model 14 means? Guess what? It's a Z. It's the Z. So what that means for us? That means same stuff. I was going to say different word, but anyway, I'll say the same word, same stuff. We'll say model. We'll accept this thing here. No, we don't accept this thing here anymore. We'll say model 14. That will be sine. That will be same stuff, and we're going to do the same model 14. We accept that, except we don't accept this. We're going to cut it off. We're going to set 0.5. Here 14. Yeah, we did that. Here we go. Oh, what happens if I will leave two lines by the JavaScript rules? It's going to override each frame, because remember, we are in render functions right now. And that's each frame animation. Each time re-renders. So even if it stays like this static, it's going to re-render static position of static object. Each time, each frame, it re-renders each time. Okay, we understand this, right? So each time it will try to move it, but then it says, oh, oops, I'm not moving it. Actually, it's a static. So that's my guess. It will stay in the same place, will not move. But maybe I'm wrong. Let's see what happens. I hope I will not break my computer. Ah, it's completely disappeared. What it says to us here. So it doesn't want to render like this. Okay, it doesn't want to render like this. Doesn't play with these rules. Doesn't want to. Doesn't want to. Okay, it doesn't want to. Okay, so let's say it's static object here. It doesn't want to again. What? 14, model 14. What's going on? Model 14 should be Z. 0.5. What happened? Did I broke my computer? What? Let's say it's model 13. It's here. What? Ah, yeah, I see what's going on. It's going, it shouldn't go behind the screen. Because why? Ah, I know. We already have model 14 here. So that's why it doesn't want to re-render. It says, wait a second. You already did model 14 here. Why are you doing model 14 again, you stupid one? That's what it's saying to me. It doesn't say it to me, but it's screaming at me right now. Okay, stop recommending this. So, but if we say, for instance, model 14 here, what it's going to do? I hope I'm recording right now. Yes, I do. And it's already, oh my goodness, it's already 30 minutes. Unbelievable. The time is flying. Okay, so if I do 0.5 towards the screen, right? No, it's opposite. It's going to move away from the screen. Let's see it. Let's do 0.5. What? I guess it's behind the screen right now. Oh no. Why? Why doesn't want? Let's say minus 0.5. What it will say to me? Yeah, I think it's behind the screen. Yeah, we can see it. Yep. Totally yes. Totally yes. You see, we can see the fragment of this object right now. Well, see, let's do it 1.0 minus 1.0. Nothing. Okay, wait a second. I didn't remove. You see, it's getting bigger. So you got the idea, right? Okay, so now we will return. Actually, we will not say nothing about it right now. We'll do it dynamically right now. Here, we'll say model 14. We'll give it a time, 0.007 seconds, and it's going to be amplitude of 0.05, and see what's going on. Why we don't? Okay, let me think. Okay, let me do it right now. This one stays. Will it move or not? It doesn't move. Is it too close? Let's do it minus 0.5. Let's do it minus 0.25. Let's do it and see if that's going to make it. No, it doesn't make it. What? I kind of get lost here. It doesn't make me, it doesn't do any mistakes. I kind of lost here. Why it doesn't do this? That's a question for me. If somebody can tell me why it doesn't move, please tell me. Let's try to do minus 2.5. Like it was here, right? So we have right amplitude. Yes, it moves now. So we were on the too close, it was too close to us. So right now it moves. It's like bumping into our head right now. Okay, so we got that, right? We got that. We all good with this. We got that. Okay. So right now it will sit in a little bit far away from us, so we can see it. So it's like inside of the perspective. Say it like this. So where's my, yeah, here. So now the question is, what, first of all, why I started from this row? Why do you think I started from this row? And I'll tell you right now, because that's the simplest row we can we can play with. Okay, so now this one, in WebGL it calls W, and it must be, I think it calls W, but if I'm wrong, tell me. If I'm wrong, tell me. It must be all the time. It must be all the time model. Okay, let's open it. We say model, and we say 15, and it would be equal. You see, it gives me 1.0 because it must be all the time 1.0 for transformations of the object. Otherwise, we'll break it. And right now, let's break it because I want to see it. I want to see it how we break it. We'll make it no, we're going to make it 0, not 1, 0. Okay, so let's see that. We reload, and I'm afraid what it's going to be right now. I'm afraid. I hope I don't break my GPU. It's broken gently because it doesn't recognize it right now for the object transformations. It ignores it right now. It's like says, no, it's not object transformation. I'm not going to do with this anything. So we'll return back model 15 1.0. Thanks, it works. It works, so don't break my GPU because there's some numbers, and there's some for lightning. There's some numbers when I can break GPU. Light source. By the way, I wanted to talk about light source, but let's finish with model first, and then we'll talk about light source. I need a drink. I'll drink right now. Okay. Okay. So we talked about this column. So that always must be 1. Let's talk about this 0, 5, and 10. 0, 5, and 10. Oh, 0, 5, and 10. That's something with something. Let's go to helpers. And you can see it's 0, 5, and 10. And this is the 1. It always must be the 1. But this also ones. Why? Why they ones? Why? Oh, yeah. Why the ones? Why that zeros? But these ones are ones. That is the question. The question is not to be or not to be. The question is why they ones, not zeros. Okay, so the question to be or not to be, that's an old question. That's a question of the past days. The nowadays question is why ones are ones here in this matrix. And I'm going to tell you this right now. Okay, I need to drink more. Okay, it's difficult to talk. What do you think? It's difficult to talk. So I'll set it on pause right now. Okay, I come back with the tea, and you know what I'm thinking about? This video already 40 minutes. It's already too long for the nowadays youngsters. and like more mature people too. So I'm going to finish video. So that's it. I'm going to run away. Okay, bye. I'll see you in next video. Yeah, I was serious. Yeah, I was completely serious. I'll see you in next video. Bye. Oh, wait a second, wait a second. Subscribe, like, and again subscribe, and again subscribe. Subscribe 1 million times to me, please. Thank you. Now I'll see you in next video.